Welcome to part 3 of our Structural Attributes series. Check out our Doug Learning section and YouTube channel for parts 1 and 2. In this series, we will review the structural attributes available in Doug Insight and look at some live examples. This video focuses on curvature, which is a measurement of how sharply bent a curve is at a particular point. As a geoscientist, it shows how fast the dip changes. Areas with high curvature show sharp edges, whereas areas of lower curvature implies a smoother, softer edge. Simply put, curvature on a surface will report each time there is a change in dip. This is helpful when identifying geological structures. For example, the curvature for a dome-like shape will be positive regardless of direction. Whereas for a valley, the curvature will be very different across the valley compared to along the valley floor. Doug Insight's curvature process creates multiple curvature attributes. The most commonly used is maximum curvature, as this shows the largest magnitude of curvature for a point regardless of direction. It is a good fault indicator as it highlights the biggest changes in dip. In this example, we're going to investigate our fault structures in more detail. We'll start by extracting maximum curvature, which can be computed for a horizon as well as a volume. In the top right map view is the pink horizon seen in the section view. Changing the property to maximum curvature is all that's required to compute the attribute on the fly. Creating a curvature volume is also fairly simple, and is derived from a pre-calculated dip field. Open the Process tab and select Dip Field. The resulting dip volume can be grouped with the seismic stack volume and displayed in the section view for quality control. The dip field algorithm is applied separately in the inline and crossline directions. Insight calculates dips by dividing the change in the vertical dimension between adjacent samples by the horizontal distance. Notice the similar input parameters to the previously calculated structural attributes. In the Process tab, create a new curvature process and give it a name, or accept the default. Add the dip field as an input to our curvature attribute. Tick Max Curvature, most positive and most negative curvature. These will generate separate curvature volumes in the Control Panel Volume tab. Select the max curvature volume for display in the map view. We can clearly see the displacement across the faults. The same attribute can also be selected in the section view. I can break this down further by displaying the most positive curvature in the top left map view and most negative curvature in the adjacent top right map view. The most positive curvature is clearly defining the upthrown side of the fault, whereas the most negative curvature shows the downthrown side. Using a combination of these curvature attributes helps determine the heave of the fault structure. Curvature attribute can be used as a helpful guide when picking detailed fault polygons. If comparing the curvature results from a surface to the results from a volume, remember to use the time slice that intersects the horizon for the location of interest. This will likely mean you need to change time slice for different locations. Watch the rest of the video series to learn more about structural attributes. If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight.